Tuttle here for Ferguson Roof Systems. For 43 years, Ferguson Roof Systems has been protecting Oklahoma's homes and businesses with quality roofing services. Their goal was to be the most honest and dependable roofing company in the state, all while providing free services such as lifetime labor warranty and annual inspections. Well, mission accomplished with thousands of client testimonials, an A+ Better Business Bureau rating, and a 5-star rating on Google. Look, the weather gives you enough to worry about, so why worry about who to trust with your roof? Call Ferguson Roof Systems today or find out more at fergusonroofsystems.com.
Hey there. A little after 9:30. It's about 9:40, so I was running a little late. I had to do another show tonight. Team Tuttle Realty. I was a little busy with that one, then I got behind. I had to work out some technical difficulties because there's always something. And then had to go look at the weather on this one, then get ready. So it took me a few extra minutes, but I made it. See, thanks for joining me out there on Rumble Land, also YouTube and Facebook. As always, like seeing your comments in there, telling me where you're watching from. The last few days, you guys have been all over the state, so it's good to see many parts of Oklahoma covered because you're all wondering if you're going to get the snow, I'm sure of it. Guys on Facebook, on the group page and on the main page, welcome as well. And as usual, I have posted the link in there where you can join the broadcast channel, which is a new thing, a new feature from Facebook. You have to be on your phone, I believe, and you have to have your Facebook Messenger installed. And if you do, what I do is I send out a little brief notice I'm going live, and that way you don't miss a broadcast. So you can check that out, and I'll post the link again. For those folks that have missed it, I usually do this about every show. That way you can always come back and get it if you miss it, or do it while you're there. All right, and of course, Miss Jody's in the house, chatting with you guys in the comments section. Okay, so let's see. I think all that's under control. And Mean Vagine, she changed her name. AT didn't like my name _mean. That's her new name now. I like your name. I like everybody's names. All right, let's get on with it, shall we? That's some big news. Big news. Are you ready for Super Bowl Snow Day? Because that's what's coming. We're not going to call it Sunday anymore. We'll call it Super Bowl Snow Day. Let's see. Out there currently, we've got 57 degrees. That is toasty for this time of the night. Man, that's not too shabby. Southwest breeze, a little bit on the light side. And we're going to continue to stay on the mild side here for a couple more days. Well, at least all of Friday. And some of you might feel a little mild on Saturday. Others be a little cool to you. And then we're going to see the big changes coming in for Saturday night as the rain starts and then the snow. So let's take a look at the latest. The National Weather Service is bringing out some key points here in the data for this particular upcoming storm system. So here is the accumulating snow potential. This is in a percentage, in other words, a probability forecast. And they like that corridor we talked about earlier today at lunchtime along the I-40 corridor out here in western Oklahoma, with the gradient kind of diminishing as you travel more to the east and more to the south and east. But pretty much everywhere in this area should see at least some snow. Now we do talk about some measuring snow, 2 to 4 inches or so is what they're going for. It's a low end. Now we're going to talk about this in a minute. We're going to get a lot more snow than that, but a lot of it's going to melt as well. Cold air again is limited with this for the ground temperatures, and the surface temperatures will be right around or just above freezing for most of the event, which offsets the snowfall. Obviously tries to melt it pretty quickly, but it also comes down pretty heavy. But anyway, the point here is that some travel impacts as you head out to your Super Bowl activities on Sunday and Sunday night. So here are some key points here, as they mentioned. 4 inches or higher. So they've kind of updated their probability forecast here across this area of the state. And wait till you look at some of the model data, man. Whew, if you thought 4 inches was a lot, you ain't seen nothing yet. Let's see. So anyway, there'll be a narrow band they're talking about of heavier snowfall. They like that corridor west along I-40. I actually kind of like that corridor, but I also kind of like this one as well, kind of in this fashion too. So we'll see what happens. We'll look at the new data here in just a second. Meanwhile, Tulsa's in on the game as well. National Weather Service there is highlighting the fact that the upper level low will kind of travel in this vicinity, and the heavier snow track is just along this path to the north and west of it. So that is why Oklahoma City is smack dab in the middle. Same thing for southwest and western Oklahoma, and of course the Texas Panhandle, and even up to Tulsa and northwest Arkansas. And they've got their little probability breakdown. We're not much happening here on the McAllister, Fort Smith, and southward zone. Too warm, just mainly cold rain and more higher probability of snow as you go up into northeast Oklahoma and thereon. So there you go. And of course, these will continue to get massaged as new data comes in. Soil temperature, so we talked about, is a main key factor in why this will not be such a nuisance because it's quite warm. Our air temperature is also not quite cold. Those are two good things, which means if you're going to have a heavy snowstorm, you might as well have it on the borderline so it melts pretty quick and doesn't affect a lot of us when it comes to, you know what I mean, work and roads and everything else for an extended period of time. So in and out is like we like it. Well, like some of you. I wouldn't mind staying around a couple days. All right, here's a look at the latest in the jet stream pattern. Look at the NAM model. We'll show you where the position of the upper energy is coming in from the western coastline, all the lift associated with that. Here's a look at it here into the southwestern part of the U.S. from the Four Corners area for Saturday. And again, this is all lift that comes in out ahead of it. So we're going to get some clouds and a little bit of rain, especially for Saturday night as well into Sunday morning. But as the main system comes in, here is Sunday morning, now wrapping up here across eastern New Mexico and then into northwestern Texas midday Sunday. And then by Sunday evening, looks like the model's backed it to the south and west a little bit from where it had at lunchtime today. So it slowed it down and it moved it back to the south and west. So it's pretty much right around Lawton, it looks like. We'll zoom in here in a second. But meanwhile, as we head into the overnight period on Sunday into Monday, you can see how that low tracks now into northwestern Arkansas. By Monday morning, that'll start to bring an end to the snow across the state. So let's take a little close-up view of that. A little refresh the page here. We're going to compare models. All right, we're going to see where that upper level low really is going to be. And it's been moving all over the place. And earlier at lunchtime, we had a big collection right over here. And now it looks like the NAM's way back here. What a difference, 6 hours can make. When it comes to a model forecast. All right, anyway, so that's the NAM model, which has the position of it, like we said, close to Wichita Falls, just south of Lawton. All right, the Canadian model kind of has a similar, it's a little elongated, but it's kind of in that vicinity. The UK Met, same idea. Let's see, we got the Icon model. Look at that, closed off right about there. GFS, right there in the middle of that, all three of them. And the European is a little more to the northeast, right about here, almost about Ardmore. So that's a pretty good tight cluster, and they'll get even tighter in overnight data into tomorrow morning. So our lunchtime live tomorrow, these should pretty much all be on top of one another because by then the models should not really disagree much at all. And the point is the track really hasn't changed. It kind of just zips on through like this, comes in like this, and it kind of comes in like this. So that's why the track goes along that I-44 corridor for heavy measurable snow and points north and west from there. So let's take a look at the timing when you get heavy precipitation. I'm going to start this on Saturday. So again, we'll have a few clouds that'll come on in for Saturday and some rain down here in Texas. We see these brighter colors of red and purple. As we head into Saturday evening, though, watch how it kind of expands a little bit here in southeast Oklahoma, so probably a little bit of rain there. As we head into the midnight hour and then some, we start to focus for Sunday morning out here across the west and southwest. So that's a big batch of heavy snow and rain that'll be developing quickly in that area. And look at those purple colors, even where it says blue. My goodness, that's some serious lift out here. In this particular case, if you get lift that heavy, you can get, of course, some thunderstorms in that. But if it's cold enough, yeah, you might actually get a little bit of thunder snow. Now I was going to click a point forecast sounding on here, just I'm curious of what it looks like underneath that mega lift. And it's 45 degrees. So at that point in time, there wouldn't be any snow, but it would be some very heavy rainfall, maybe a little bit of thunder with it. As we head into the midday, or mid-morning, I should say, on Sunday, very heavy rain signature here. I mean, buckets. Build an arc type heavy rainfall rates here across southern and south central and central Oklahoma. Again, not quite in the snow category yet. The snow will be out here in this colder region back here in this lift, but good rainfall across eastern Oklahoma through lunchtime. Okay, so then what happens is, remember, if we're going to envision our low right here, we like to have the area for snow kind of on the northern fringe of it, kind of in a wraparound like this. So when you kind of picture that low moving to the northeast like this, you kind of envision this wraparound going along with it. So that's why the changeover is a little late here. So this is mid-afternoon, so you kind of have to get that low a little closer to you so you get into the cold air. But needless to say, you can see where this lift is kind of focused on, and this is right along the I-44 corridor from Tulsa to Oklahoma City, back down to Lawton, then out west on I-40. Kind of outlines that little red thing I started the broadcast with, where I think the heaviest snow would be in the most favorable location for that. Okay, so let's go to the overnight period. You can see how that continues to move into the Tulsa area, northeast Oklahoma. And by overnight, midnight into Monday morning, it starts to move out of the state little by little, pressing into Arkansas and Missouri. And that's it for our little snow system. So it's a Sunday morning to Monday morning, 24-hour event. Dry slot, where is it? Who's going to get hosed? Somebody gets hosed. Who's it going to be? All right, the darker brown colors, that's the dry air in the mid-levels. Here, let's see, that's for Saturday evening. We don't care about that one. That's just behind the first wave of rain. All right, here comes the next one. Here we come. Look at that. Right up here, it's in northern Texas, zipping on into southwest Oklahoma by midday on Sunday. So that's right about lunchtime. Again, Oklahoma City is right here in the middle. All right, so let's go on inward. Oh, look what it does here. By mid-afternoon, 2, 3 o'clock, a dry slot's knocking on our door down here in southern Oklahoma. And then it starts to shift off to the east by the evening, 6 and 7 o'clock. But if you noticed my little circle here, we had a little taste of it, but that was about it. Otherwise, it stayed pretty moist here across Oklahoma City metro area. Points to the west and southwest and north. All right, let's go into the evening hours. That dry slot continues to move off to the east around Tulsa and points east from there. Wrap around, some rain and snow. Rain for North Texas, snow for us. And then there's more snow there for the midnight hours. Wrap around has completely cleared for the state, so no more dry air to work with. Is all across Arkansas at that point. So it's a transient, small area of dry air that does move through. It's not enough to stop the snowfall accumulations here in the greater Oklahoma City metro area, but it will kind of keep the limiting factor in Tulsa for a while until the final wraparound moves through. So yes, there'll be this little transient of dry air. Now temperatures we talked about, it was nice today, man, 60s and 70s. All right, so for tomorrow, we're going to kind of repeat you on that deal. So in the afternoon hours, lots of 60s. And if we look right here, yeah, there's a few 70s showing up, especially south central and southeastern Oklahoma. There's a weak front that'll be coming on in, and that will cool temperatures down overnight, Friday night, into Saturday. So we're going to start you on Saturday morning into the 40s and some 30s, and they're going to rebound you into the 50s. That's what I'm saying. Some of you might think that's still pretty mild. It's certainly not 70, but so it's not 30 either. All right, let's go on into Sunday morning hours. We're down to the 30s to around 40 in most of central, northern, western Oklahoma. And as that precipitation develops and gets heavier, you'll notice this little green line get darker. This is cold air that is transferring down from top to bottom. All right, we don't have another cold front coming in. It's just precipitation that's falling. And as the core of the upper level low intensifies and strengthens, it'll bring down some of that dynamic cooling effect to the surface and drop our temperatures down. And with that heavier snowfall, of course, will also help to cool the temperatures at the surface. So if you look here at noontime, this is kind of where you're going to get your favorable snow band. Because at 36 is just probably about a degree too warm. It'll be real close at lunchtime. 34 in Stillwaters might be it. 35 here in Enid. Again, this is assuming the model is absolutely perfect on temperatures, which, obviously going to be a little bit of wiggle room. But kind of gives you the idea of where the nose of the rain is changing over to snow, where you see this by lunchtime on Sunday. As you go into the 3 o'clock hour, that shifts more southward, does something like this. All right, and then as we go into the 6 p.m., kind of same holding tight. There's your big snow region in this secondary blue line, so this whole area underneath the blue line. Excuse me. Now I get all choked up over this. 9 o'clock, there's the expanding into northeast Oklahoma now. So in other words, where any rainfall will be converting over to snow by the evening hours. So it takes pretty much all day for Sunday. About the time the game ends is when you guys will start to get your snow over here in Tulsa. Otherwise, for the rest of the overnight period, you see how it gets colder elsewhere across the state. And then we'll have some colder that filters in behind it with the northwest wind as the system departs. So that's kind of the breakdown of how that happens. Let's take a look at the timing and the big location of it. So we'll start you off in the New Mexico and Colorado area for snow. Meanwhile, rain here for southern Oklahoma, North Texas, Saturday mid-afternoon to late afternoon. There is across southeastern Oklahoma. Otherwise, there's that snowfall from southwestern Kansas, moving on into, for late Saturday night, into Texas Panhandle. All right, and now we go into the morning hours for Sunday, so it's already snowing along the border states, border counties, out westward, and then that snow just slowly expands eastward. The extent of the snow looks like so far kind of cuts the Panhandle, about like so. Let's see what happens if we get south of that line. We go into the Sunday evening. A little bit of flurry activity does drip down here in this zone. Not probably anything too measurable, though. And then as we head into the next few hours, this stuff dries up by Monday morning, and it lifts on off to the north and east. So that means no snow for you guys in Dallas-Fort Worth, and we'll get wraparound snow through the daybreak hours on Monday here across the northeastern quadrant of the state, bounded by I-35 and I-40. Otherwise, more snow up there for Missouri. So that's the big picture for you guys for this whole event. Now let's look at Oklahoma in specifics and give you the timing on the arrival so you can plan your Super Bowl Sunday. So obviously, when you do head out, you're going to have to deal with blowing snow, low visibilities, cold, of course. And the roadways, at first may be pretty decent, but at some point the snow rate will overtake the warming rate, and you will have obviously some slippery roadways to deal with. Here is a look at 6 a.m. So you see out in the Panhandle toward Little, Kansas, Dalhart, Amarillo, and then Elk City's getting in the action. Cold rain here in Oklahoma City, central Oklahoma through noontime. All right, so remember, we talked about how at noon these temperatures are starting to kind of cool from right about this area down. So here's where the model tries to change it over into snow. And there we go to 3 o'clock in the afternoon. So it's kind of fighting us here in Oklahoma City. So you kind of cut the metro in half. North and west side is already getting the snow. Eastern side probably still a cold rain of 35 or 36 degrees. And as we head into the 6 o'clock hour, we do change over from the 3 to 6 o'clock hour. So there you go, changing over all snow here in Oklahoma City, points north and west. Heavy snow at that. Then it moves on into Tulsa areas we talked about around 9 o'clock or so, and around Bartlesville, some more heavy snow up around Stillwater, Elk City, southwest Oklahoma toward Lawton. There's midnight hour, still some heavy snow here in Oklahoma City, and then it starts to wind down. There's 3 o'clock in the morning, and then there's 6 a.m. The model stops at this point in time, but it continues to move slowly out over the next few hours after that. Snowfall amounts. Remember, we're not into Friday yet, so these still won't be accurate, but it gives us an idea where the trend has been. All right. This is fun. Okay, so this is the NAM model, which, by the way, I do not use for snowfall amounts. But if we were to use that, using the Kuchar method, up around 30 inches of snow here in the Panhandle area and right around Elk City. That's crazy, right? The Canadian model, interesting enough, this goes through, by the way, Monday morning for measurable snow. Doesn't have any measurable snow here. Can you believe that? It has all the snow just out here. I mean, the Canadian model has been really interesting this whole forecast cycle. The Icon model, the German model, got the nice little strip like this, comes through just around Tulsa and Oklahoma City. It's on the south side of the I-44 corridor. So in other words, when I say, because somebody asked me this once, what does corridor mean? Corridor means along a boundary. In this case, you say the highway, the interstate. And because a lot of people know where the interstate of I-44, the turnpike is, a lot of people know where I-35 is. I-35 runs north-south, I-44 runs northeast-southwest. So you say the corridor, meaning along that boundary and then kind of on either side of it. That would be the corridor. So anyway, so that's kind of a point of reference just to make it easy when you're looking at a big picture like this, so you can get your proximity. All right, so anyway, that was the Icon model. The American model has it more on the north side of I-44 and out toward I-40, but most of the heavy stuff out here in the western half of the state versus anywhere else. And the European model, similar to what we had drawn here for the Icon model, but it's got just a little nudge to the north. So it's liking I-44 right down the middle with the heavier stuff out here in the southwest versus up to the northeast. Okay, so let's get closer end of that so you can see what that looks like. So if we just take a look at the European, we're looking at 4 to 5 inches here from Oklahoma City out just to the west, Yukon to 7 inches, even back out here in southwest Oklahoma, 8, up at the Panhandle close to a foot. Over here in Tulsa, there's 2, and out there to north and east from there. The American model, like we talked about, had a big bullseye of about 15 inches here. There's some weird bullseyes here in the model data of 5 and 6 inches with feast and famine everywhere else, which is odd. But regardless, that's just the trend in the general area. The Icon model, like we mentioned earlier, also kind of similar to the Euro, just to pick your poison on the position, a little bit more to the south. For example, it would have Edmond in the dusting to flurry range and Guthrie, where it would have Norman down here in the 6-inch range. That would be lame. I would not like that outcome. The NAM model, this is the fun one. It's got 6, 7, 8, 9 inches of snow from Oklahoma City to Stillwater up to north of Tulsa to Bartlesville, then back out here from Kingfisher toward Elk City in the Panhandle. So this, I just let you know, and this is why I'm showing you this, because if you haven't watched in the last couple of days, we've been focusing on this is how much snow will fall and be generated by the atmosphere. All right, that does not mean what you're going to be able to measure, because we have the warm ground temperatures, the surface temperatures are still a little warm. And so you end up melting a lot of that stuff. And so when you melt a lot of that stuff, the amounts you have to cut sometimes in half or maybe even more. But like, for example, we saw some of those crazy numbers, right? Like here's the NAM where it had 30 inches of snow. Well, now it's got 14. So it basically cut it in half with the melting. That's still a lot of snow across the state, even if that were verified. And that's crazy. The Icon model, though, when you melt all of its snow output, we're looking at 2 to 3 inches of snow. I mean, look at this little thin stretch here. How sad that would be if this actually panned out. You know, how many people be upset here and how many people upset down here. The American model, it just melted it all. It said, forget this, man. I'm not going to have any snow on the map. You know, and then the European model melted about half of it, but still some decent amounts, anywhere from 1 to 2 to 3 to 4, maybe 5 inches of snow along that corridor, the convention. You know, right along I-44 here, goes down to here, then I-40 out west. So kind of the reason why I kind of like my broadcast, I did something like this, if you recall. So that's kind of the reason why. I kind of like that blend when you put them all together as far as the heavier snow. And the amounts, yeah, I could definitely see several inches of snow, especially out southwestern Oklahoma. And even here in the metro, it's still possible. Again, nobody's going to know the exact melting rate, but the models are just insistent on producing a lot of snow. The European, we go to the ensemble views, there's 1, 2, these little blank lines, 3, 4. 4 out of 50 say no snow, buddy. But the other 46 say Katie bar the doors. Some of these around 10 inches, 14 inches, 10 inches. This is Oklahoma City, 11, 8, 9, 10. So my goodness, man. I mean, the European has been going nuts with this thing since day one, it seems like. All right, so let's take a look at, if you were to look at all that on a flat plane as to how much snow the models think is going to be in this area. All right, we'll go look at some of the European output. Let's see. So you can see how it kind of moves around. See the big bullseyes kind of go over different spots. That's why it's funny to do snowfall prediction, because they're so wild. The SREF, which is a high resolution model, went nuts with 2 feet to almost 3 feet of snow around Amarillo, and then east from there in one of its runs. The Canadian model's all over the place, like this, from feast or famine to nothing. Anyway, so there's others, but that's just kind of the general idea. I want to show you that there's still a lot of model variability. And when you do look at the SREF, and I want to show you this I'll show you in the vertical here in a minute, but I want to show you this on this plot here. It's easy to see. And now, let me see if I can scoot this over, because you might not make out this number. Yeah, it's right here on the edge. Okay, so I don't know if you can see this or not. This right here is a 5. That stands for 5 inches of snow. So the black line is the average of all of its members. So the black line says in Oklahoma City, that's an average of 5 inches of snow. Some of them say a little lower. I get that. And some of them say much higher. Here's one that says 20 inches of snow. If we had 20 inches of snow, I wouldn't know what to do with myself. All right, so just to show you that there's still a lot of variability in the snowfall forecast, which is why, again, we should wait till Friday to start giving you more ideal estimates, other than the fact several inches is a safe call. But still, there's going to be a lot of melting. Okay, so here's a look at the overall winter impacts. Now, the impact is the probability map. 60, 70, 80, 90% here as you get to the darker red. And that means travel conditions, for most part, with this situation, since it's just snow and blowing snow. And this takes us through Sunday in the evening hours. All right, so if we go from there, next panel over, of course, as we head into Monday morning, it will expand. So it'll cover parts of Missouri and Arkansas. See, not so bad. This is a minor probability, by the way. So it's high on the minor. In other words, more of a nuisance versus something that's life-threatening or really terrible. If you were to blend that together here through Sunday morning, you can see how most of the moderate impacts are out here across western Oklahoma. And, of course, on that other map, if we extend it, it would have minor to maybe spots of moderate north and east from there as we go through the rest of Sunday to Monday morning. Okay. Temperatures. So, like I said, tomorrow's still pretty decent. And Saturday not bad either, really, considering. But Sunday we'll spend the day in the 30s, and we'll start you off below freezing. So any rain, water, snow, whatever's on the ground, temperatures, once they get below freezing, you have to watch the roadways, bridges and overpasses on Monday morning. So will there be school closings? I don't know. I can't tell you. Will there be some delays? Probably because of some slick spots. I'm certain there will be. Otherwise, we'll warm you up in the afternoon, 45, melt most of the snow. Whatever snow is not melted will be gone here for Tuesday. All right, so before I let you go, a little fun here. We'll look at this on the side view. So this is the NAM model. We're going to do Oklahoma City. I'm just going to show you what it is producing as far as the look. Okay, so this is why the models are so confident, other than the fact the placement of certain position of features that I've told you about. But if you look at those in a cross-section of atmosphere, all right, so if you've never seen this before, the surface where we live and breathe is down here, and this is the top of the atmosphere around 20,000 feet. So we're going up with height, okay? H, this is height. All right, now the time frame, believe it or not, T for time goes to the left, which is backwards. Your brain's not going to like it. It's fine. It's whatever. Deal with it. On this map, it's just the way it is. I can't change it. I wish I could because it annoys me. Anyway, so if we look at the time, what we're going to look at, all this green you see on the map is moisture. So there's a lot of moisture in the atmosphere. All right, so that we got in place. Here's a snow growth layer right here. So the moisture is in between the snow growth layer for sure, and even below it. So good to go. And then with final equation here, we have a lot of red. These little circles that are all over the place. This is omega, or lift in the atmosphere. Looks like I'm crawling with a cartoon with a crayon. The point is, there's so much lift, so much moisture. You could not get the amount of rain and snow we're going to get out of this. Speaking of which, the models are going about 1 inch to 1.5 inches of rainfall before it changes over to snow here in central Oklahoma. Now, when it does change over to snow, this NAM model happens to have about 5 inches of snow here for Oklahoma City when you add it up for us. Now, if we go to Tulsa, for example, see what the NAM does for you. It gives you about 4.5 inches of snow. That's not bad. So I'm going to show you what's fun. I'm going to show you what's fun. Actually, do the GFS first, and then I'll show you the fun one. All right, GFS for Tulsa, like 1.5 inches. So that's pretty lame, right? Because it's got a very thin, narrow region, and also, remember, it melted a lot of it. And then same thing with Oklahoma City has 2.5 for Oklahoma City. All right, let's go to the, this is the fun model. This is why I was going to pull this up. So back to Oklahoma City in this one. I want to show you just what it can do. All right, so I'll show you, this is a few different runs in it. So this is that high resolution SREF model. And what we're going to focus on out here is the column of whites that go up, which is the amount of snow that the model accumulates. So this one doesn't have any. It's got 1/2 inch of snow. All right, remember it's the same spot. The model run different ways, different ingredients, different variables added to it. Okay, so this one only has 2.5 inches of snow. Okay, the other one had a dusting. This one, 15 inches of snow. You see that right? Did I say that? Yeah, it says 15 inches of snow in Oklahoma City. All right, this one says 7 inches of snow. All right, this one, no snow, just a little rain. How about that? This one's got 29 inches of snow. 29, Oklahoma City. Good grief. All right, this one, it's got 10. I'm loving this SREF. It's nuts. All right, this one's got nothing. Cold rain. All right, remember, this is the same model, nudge different directions. This is 20 inches of snow. All right, this one's got 3 inches of snow. This one's got 12 inches of snow. This has got nothing, just cold rain. All right, another one with cold rain. This one's got 6 inches of snow. All right, that's a cold rain, cold rain, cold rain, cold rain, cold rain, cold rain, cold rain. Here's some more snow, 17 inches. Here's another one, 8 inches. Here's another one with the dusting. And here's another one here, 3 inches, and it looks like cold rain and a dusting. Oh, 4 inches, 5 inches. There you go. That's the SREF. So it's a very high resolution model, short term. And it's supposed to have a really good grasp at precipitation in the atmosphere and factors to be able to convert it over to rain or snow. So what this model is telling you is that it's nervous, which makes me nervous. What it does is it has plenty of moisture. All right, that's not even in question. But what it struggles with is those temperatures to be critical enough to where it changes over to snow and it doesn't stay as a cold rain at 36 degrees, right, or 37 degrees. And so the model is right on the cusp. What happens is when it goes just over the edge, that heavy rainfall of 1 to 2 inches now all of a sudden turns into 1 to 2 feet of snow. So it's like this. I just happen to pick a point in Oklahoma City, which I believe is probably centered at Will Rogers Airport or downtown. I didn't look at the actual GPS, but let's just say it's downtown, so it's splitting the city in half or whatever. That's kind of the fine line we're talking about, and that's fun. I mean, that's exciting to see that. It's crazy, but could you imagine if you had that kind of snow here? I'd be really happy. And remember, it's going to melt pretty quick, so it really wouldn't matter. Even if it snowed 20 inches, you probably couldn't measure 20. Maybe you'd measure 10. It just depends. It just depends on how fast it can melt, because it's going to melt not at the same rate it falls, but at a pretty good rate. So you'd have to be on top of it pretty quick. All right, so I'm going to go back. There's some new data did come in while we're looking at that, and so I just want to see the position of it. So this would be the new Canadian and the GFS. So let's see here. Okay, so the GFS has that low a little bit more to the southwest. Ooh, if that's a new trend, we're in trouble. The Canadian also has a little bit more to the south. It's still open. Uh-oh. Oh, boy. This is why I get a little nervous when it's still this much variability. I mean, you see the output, and you see how you can go really excited about snow, right? But you see these little things here, and so they put the little low right about smack here on the GFS. And the Canadian, for what it's worth, looks like it's pretty close to the same ballpark. Earlier, the NAM had the low about here. And let's see, the European had the low here. So really all it's done is kind of shifted it back south and west at the same time frame of Sunday evening. So we shall see. Remember, the exact track is where it matters because you have to have the snow north and west of that, but it also has to be favorable to produce the snow, and you have to have enough cold air in place or to generate. So we shall see what happens. Let me see what the snowfall totals did with that little shift. See if that made a difference. Let's see. We'll go to this one first. Let's do. All right. Oh my gosh. It's ridiculous. All right, let me see something here. All right, this is why this is fun, man. This is why this is fun. Okay, so the American model, because it's a little bit more of the south, is probably not quite as closed off. It probably has a little too much warm air now infiltrated into central Oklahoma as a result of that. I'll have to look at the other panels of data with it, but just looking at this output of snow as a result of that. When we started this broadcast, it was the Canadian that had most of the snow all out here in far western Oklahoma and the Panhandle, and nothing else across state. And now the American model has done that. So that's interesting. That's two. That's two for going no snow. You don't want to see that trend develop, as you head into an event. But that does happen. I've seen that happen a lot of times. You start to get all excited. There's a lot of model agreement, and then easy come, easy go, and they take it away. When you're at this deal where you've got this much cold air to work with, teeny tiny bits, it's not a guarantee, even though the models can get really excited with it because, like I said, they're on that line where it can go one way or the other. And if it goes one way, it's a cold rain. If it goes the other way, it's bukus of snow. And it looks like to me the models are having a tough time, not only SREF that we looked at the high resonance stuff, but even the global models for the GFS and the Canadians. Let's do this one. So. See, in forecasting fun. All right, so here is the Canadian model. We started the broadcast with it had the edge out here in the western third of the state, right? And then the GFS, now it's got even further out west. And then as the system pulls away on Monday morning, it's got a little wrap around here. And this the reason why is because out here in this terrain of Arkansas, you get the valley areas and stuff. It's colder, little pocket of colder air. So it means it's got the air too warm here by just a degree, probably 1 degree too warm, and it keeps it all rain here across the rest of the state. I will say the GFS isn't necessarily a strong suit when it comes to low-level thermodynamic profile with surface temperatures. It can be off by just about a degree or two, which would explain the output. But man, that's a big change, right? I still would side more at this point in the game with the European. It's been pretty consistent once it got out of its little hiccup Monday and Tuesday this week. It had the system. It liked what it saw. It got scared Monday, Tuesday, and then it came back online, I think, Tuesday night, Wednesday. And then from there, it's been locked in. So it's going to be interesting to see what happens. I said tomorrow at lunchtime would be the day we start to give you official snowfall totals, and seeing this new trend here at the last minute makes me very uneasy. Very, very uneasy. It'll still snow, across the state, and you can still have the snow rain mix, elsewhere over Oklahoma. If it's too much of that mix and more of that cold rain, you won't even be able to measure it, which is obviously what those two models are indicating. except for out west where the colder air is more entrenched. But that's interesting, man. We just we saw anywhere from nothing to 30 inches of snow and a variety of model outputs for the same storm system and the same pattern, same position, same track. That's impressive. So there you go. So if you're asking me, okay, Aaron, well, what's your forecast? Shoot, this is where it stinks, man. Because if you're forced to do it here and you can't change it, like I said last night, I had to go with the same idea. I-44 corridor, heavier mounts from Oklahoma City west on I-40 as you go toward the Texas Panhandle, and kind of southwest toward Lawton and back out west, kind of a little sweet spot. I'd still go for that, and I'd still go a few inches of snow, which few means 3, 4, 5. So that would be my forecast for that. And how much of that melts, probably a little bit, because that's probably including already some melting. So I think that's probably a pretty good total as far as measurable snow goes. But that's looking at all the data I've seen so far up to this point. And then I would have to see the data overnight and tomorrow morning come in. That goes more toward the warmer view. And I'd have to analyze, obviously I'm not going to do it tonight, but I have to analyze more on the data side as to why those other two models are saying, you know what, not get quite warm enough. It's going to be a little just a cold rain. I mean, I can do that here just real quick with the sounding profile forecast. And we'll do that. So let me, let's do this. I'm just curious what the GFS is doing. Yeah, so because it has that low a little bit more to the south. Remember, we had the upper low was just a little bit, another 50, 60, 70 miles southwest. That pulls everything back south with it. So for Oklahoma City, for example, Sunday evening, I'll go like Tuttle. Pick a sounding spot in Tuttle. So yeah, this is why. You got to get more underneath the core of that upper low to get the dynamic cooling. And we just don't have it here. So we have a temperature of 40 degrees at the surface. That is too warm. That is a cold rain. So that track of that upper low makes all the difference. And if that's a little jot to the south and it holds, that is why we're too warm. And it's just going to be a cold rain for our Super Bowl snow day in Oklahoma City. Man, that would be lame. Yes, I want snow, so that would be lame. All right, let's go to Sunday midnight. Let's see what happens on the wraparound. 38 degrees. Yep, too warm. What about you, Tulsa? 41. Okay. And then by daybreak, as that low kind of jots northward, it does have 37. So it's struggling to produce some wet snowflakes here in northeast Oklahoma as it leaves, but that's about it, and that doesn't look all that likely. Okay, so... Oh my gosh, that is so lame. It is what it is, man. It is what it is. So, still looking for snow, still looking for cold rain. Moving from west to east Sunday. And so, if you are going out for your Super Bowl plan, just know that is still in the forecast, but know that official amounts and totals are not done deal. And there's still potential for some monkey business where the track of the low hoses us, goes a little bit more to the south, and we get a cold rain with 38, 40 degrees versus a big wet snowflake situation of 33 to 35 degrees. So we shall see. The GFS, again, isn't the best model for low-level temperatures, but I don't like to see that trend, and the Canadian model went with it. The NAM, when I see that, it's a better model for low-level stuff, as well as the HER and some of these other mesoscale models that we can look at. And the Euro doesn't do too bad either, so we'll see what those do as we head into tomorrow, because they'll start to get into the window of the high resolution timeframes of 48 hours to 60 hours, and then we'll be able to answer that a lot better. But that's what I got here for you for tonight. This is fun. a little twist in the storyline. All right, you guys have a great night tonight, and join me for Lunchtime Live tomorrow. We'll see what's changed. We'll see if we're still looking at snow or if it's going to go all the way over to rain. Oh, it's going to hurt me if that does. All right, you guys be good. We'll talk soon. Take care.